Hello everyone. Today we will discuss data aggregation with SQL, fascinating and helpful topic for data analysts. Are you ready to get started? When dealing with large datasets, aggregation is a crucial concept. For instance, examining trends for various countries or socioeconomic groups can be more informative when analyzing climate change data than focusing on a single global average value. This tutorial we use the group by, where, and having clauses. Additionally, it's worth noting that these topics are frequently discussed during job interviews. So, paying close attention is recommended. This tutorial, we use a climate analysis database for practical exercises. This database contains various socioeconomic and climate metrics for different countries. The primary table, named Climate, contains essential data such as water technology adaptation, GDP per capita, school enrollment rate, water stress index, and more. This comprehensive dataset provides a detailed overview of the global climate challenges. Now that we know the source of our data, we can explore the specifics of SQL clauses covered in this tutorial. The group by clause is crucial in aggregating data in SQL. It works in three basic steps: split, apply, and combine. Although the explanation may be complex, let's explore some practical examples to understand it better. This query identifies the top 5 countries with the highest average water stress over the years. We divide the data into groups based on the unique values in the country column. Then, we apply the average aggregate function, AVG, to each group's water stress index column. Finally, we combine the results into a table, sorting the countries by the average water stress index in descending order, limiting the results to the top 5. This second example calculates each country's average GDP per capita, recorded years, and the average water stress index. We divide the data into groups in the query based on the unique values in the country column. We apply several aggregate functions, the average, AVG, for the GDP per capita and water stress index columns, and the count for the year column. Finally, we combine the results into a table, sorting the countries by average GDP per capita in descending order. As we can see, the previous results have null values that could make the analysis incorrect, as in the case of the first query we examined. To remove them, it is necessary to proceed with data filtering. However, although group by is mighty, the latter has limitations, especially when dealing with aggregate functions. This is the where clause that comes in and is undoubtedly the most commonly used when filtering data in SQL. In turn, however, where also has limitations regarding aggregation. Let's look at an example to understand better what these limitations are. As you can see, this query returns an error. The error is due to the inability to pass aggregate functions in the where clause. This is because in the SQL clause execution order, where is processed before that aggregation, thus making it impossible to use at this stage. But do not worry, there is a way around this limitation, and it is called having. Having overcomes the limitation of where by allowing us to filter aggregated data. Let's see how it works in this example, where we aggregate data by countries and filter out those with an average water stress index above a certain value. Notice how this query generates no errors. This is the power of having, which allows aggregate functions to filter the data, unlike the where clause. To understand more, consider another example in which we want to identify countries with an average GDP per capita above 20,000 and a water stress index below 40%. Again, the query generates no errors, further demonstrating the flexibility of the having clause in working with aggregate data. Be careful, however, when using aliases in aggregate functions. Remember that using aliases in aggregate functions within the having clause can generate errors, since the definition of aliases occurs only after the execution of having during the select phase. Let us look at an example. The query returns an error due to using the alias aggGDP in the having clause. The alias is generated with the select clause, which, however, is executed after having, hence the source of the error. In practice, when having is completed, the new column named aggGDP does not yet exist. Therefore, filtering the query cannot proceed. The problem is solved by modifying the query by removing the reference to the alias. This time, the query returned no errors, and we could filter the data correctly. Thus, we must never forget that the column aliases cannot be used in having, because their generation occurs later with select. Finally, going back to the first query of the exercise, by adding is not null to the having clause, we can exclude the result with a null min ID stress value from the final output, thus obtaining the correct list. To avoid errors such as those we have discussed, it is critical to understand the order of the execution of SQL clauses. The actual order of the execution is as follows. However, when we write a query, we tend to use the following sorting, which differs from the actual sorting. The actual order then involves executing the query with from, which indicates the tables to be used, and select is performed only after having. This explains why having cannot use aliases, while order by can. Order by is executed after select, when aliases have already been defined. This understanding of execution order also explains why having is used in conjunction with group by to apply conditions on aggregated data, while where cannot do so. Now that we have gone through the whole thing with various examples, it is time to draw conclusions and to conclude this tutorial. To summarize, the fundamental difference between where and having lies in when they filter the data. Where does it before aggregation, while having does it after. This distinction and understanding of the order in which SQL clauses are executed in a query are also particularly valued in job interviews. As a technical note, remember that the queries in this tutorial are optimized for PostgreSQL. Some modifications may be necessary if you use another DBMS, for example MySQL or SQL Server. Well, we have reached the end. Thank you for following this tutorial, and if you found it helpful, please leave a like. Thank you, and until next time.